My name is Hamid Jamshidfar. Today I'm going to show you how to solve the questions regarding trusses. For example, a question like this. Some forces are applied on some joints and you're asked about finding the internal forces in different links and say that it's tension or compression and these kind of problems. We generally name truss problems. And today I'm trying to show you how to do trusses in 2D, not 3D. At the beginning I want to show you how to find zero force members, meaning that when you are facing with problems like this, some of the members may have zero forces, meaning that they cannot have any compression or tension. And that's the first question. Why we need to answer this question at the beginning? Because this makes the mechanism much simpler, meaning that, for example, if you know this guy is a zero force member, you don't need to consider that, and that reduces the number of links and the number of unknowns. And for example, if you know this and these are zero force members, meaning that you deleted two links at the beginning and you don't care about those, and you can assume that your structure doesn't have those links, and those links are ignored. And that would be very helpful in solving the trusses, because in many cases we are facing with a great number of links, and deleting some of them can be very helpful at the beginning. And that's the first thing that I try to show you how to find. And then after that, there are two approaches for solving the truss questions, and one of them is going joint by joint. The other one is doing the cuts, and I try to show you how to use those approaches. Okay, let's go to see what is the zero force member and how we can find them. Let's assume this is a truss with a number of links, and you're looking for the links which cannot have any forces. One of the links is AD in this picture, and if you consider a joint like D, we can say these are the forces which are applied on the joint D, meaning that if I have a pin over here and I do the free body diagram for that pin, disconnect everything connected to that and put the corresponding force over there, I would have such a arrangement of the forces. And let's assume you get your coordinate like X and Y at that point, and we are doing the static problems, then meaning every part of this structure should be in the static equilibrium conditions, meaning that the forces here should be in equilibrium. If you do this and write down the sigma of X and sigma of Y, you see this force should be 0 and these two should be equal. Why this should be 0? Because there is no other forces in front of that to cancel, meaning that I'm pretty sure there is only one force in this direction and there is nothing in front of that. If I write down sigma of X, let's assume this is X, meaning that you have only one force in that direction. That force cannot be any other value other than 0. That should be 0. And the same story for these two. There is no other forces in front of FDB, and we have only FDE, meaning that these two forces should be equal. Right now we're pretty sure this is 0. When a link is not applying forces, we can ignore that, meaning that you can ignore this. The same story here. Let's assume you got point C or the joint C, and you do the free body diagram for that point. The forces which are applied at that pin would be one of the forces which is applied by CB, the other force which is applied by CD, and the other force is FCA. If you write down the equations of the forces, the static equilibrium equations for the forces, you can see that there is no other forces in this direction. We have only FCA times sine theta. We are pretty sure that sine theta is not 0 because it has a value. Then FCA should be 0, meaning that it doesn't depend on the angle. Here we have a rectangle thing, a right angle thing, but here we have an arbitrary angle actually, and meaning that this should be 0. FCA should be 0, and it cannot have any other value other than that. There is no forces to balance the x direction, and these forces start to move to point C, and we are pretty sure this is static. That means you don't have any values for this. Okay, here is a simplified version of the first truss, meaning that we need only consider 3 parts. We can ignore these 2 links and get rid of them and focus on this problem, meaning that at the beginning we do a huge simplification, and that would be very helpful because it reduces the number of unknowns and can help us to focus on what is actually unknown. And these 2 are right now 0, and we have a value for them, and right now we have some non-zero values for the other links, and we can go ahead with this problem. Okay, let's do some practice right now and try to find some of the zero force members in these problems. I'm going to do some reasonings and find the zero force members. At the beginning, I'm looking for the links which have these conditions. One of the condition is that we need to have three links connected to a point, connected to a joint, and the second condition is that 2 of the links are exactly in front of each other, or in a line, meaning that they should be exactly in front of each other. Okay, let's go ahead here and try to find some of them. Okay, here I have three links, 1, 2, 3, and 2 of them are on one line, meaning that the line CD exactly is the line DE and is the line CE. Okay, right now you can say there is no other links here to cancel the effect of this guy, and this should be 0, meaning that this is 0 force member. I can get rid of that. Let's continue our search. What about this one? This is not a 0 force member. This is exactly the same configuration, but we have an external force. Then the third condition we can mention, that is that there should not be any external force. There is no external forces in that point, meaning that as soon as you see an external forces at that point, you cannot say this is a 0 force member. And the reason is clear. This guy here, let's get back here. Here, there is nothing in front of this. Then, if this guy applies some forces, this point start to move in this direction, or get in this direction. But here, we need a link to fight this, to keep this point in a static equilibrium condition, meaning that we have exactly 2 kilonewtons in this link to fight with this, cancel out the effect of this and keep this point in its position. Okay, this is not a zero force member. What about this one? No, because we have 1, 2, 3, 4 links. The first condition is that we need to have 3 links connected to a joint. Then this guy cannot be a zero force member. This cannot be a zero force member as well, and we ignore here, right? What about this one? Yes, it is, because 1, 2, 3, no external forces on that joint, and 2 of them are exactly in front of each other. You may consider this, but this is not the point we are talking about. We are talking about G. When we are talking about G, we ignore about the rest of the structure. We just look at this and do a cut like this and consider 3 links, no external forces, 2 of them in front of each other. Then this would be another zero force member. We can ignore that and simplify our mechanism based on that. Okay, one of the things that you need to be very careful about is that right now we can consider point F. We already removed this, meaning that we ignore this totally. Then point F in the new arrangement has 1, 2, 3 links, and we ignore this guy because this guy got 0 from point D, and it's a zero force member when we were investigating point D. And right now we need to consider this joint with only 3 links. Then this one should be the zero force member as well. Okay, we start to do review. I just double check every joint. A is not dealing with the zero force members because it has 2 connections. B doesn't have any zero force member because this guy is fighting with this. C has a lot of connections like 1, 2, 3, 4. One of them got 0, but it still has 1, 2, 3, 4 links, and an external force doesn't give us any zero force member. D already gave us 1. E has 2 links. F, we did that actually. We removed this guy and F gave us this as a zero force member. G, this guy got 0. H, no, because it has 4 and we are pretty sure one of them is not 0 and we cannot calculate. Then this structure could be simplified by removing these 3 links, and you can solve it with ignoring these 3 links, meaning that it could be much simpler than in the case that you consider every links like these ones. Okay, let's go to another example here. Then I start from point or joint A, B, C, D, E. Okay, A is not dealing with 3 links. B is not giving us any zero force member because we have external forces. C has 3 links, but we cannot say that 2 of them are on one line, meaning that all of these ones can have values. D has 2 links and E has 4 links, meaning that this structure doesn't have any zero force member. Okay, let's continue to some other examples. I'm going from A. No, it has 3 links, but we know that there is none of them is in front of each other. B has 4, C has 4, and also external forces. The reaction force here is an external force. We need to consider that. And what about this? This is a special case that we need to be. We can consider that as a special case of zero force members. Actually, if we have a force in this direction, there is nothing in front of that to cancel out that, and this one as well, meaning that these two forces, these two links are zero force members. Then I would add a special case, like when could be a special case of zero force members when we have two links, only two links, and no external force on joint, and links, and those links are perpendicular to each other. And the reason is clear, because if there is some forces here, there is nobody in front of that to keep this joint, and this start to move to the left or right. The same story here, we cannot have any. Okay, right now I ignore these two. I consider E with two links. It is not a zero force member, it doesn't have any zero force member, and we cannot say that there is any. The same story for F, and the same story for G, but here we have H as well. H has the same condition of D, and it should be a zero force member, and these two are zero. Okay, let's get back to E and see what is happening in E. Actually, in E we have two links. If this guy has some force, we are pretty sure that these two are zero, because they cannot cancel out each other. We have the same story here as well, meaning that, okay, I have one force here and one force here. I can say this force may cancel out the effect of the horizontal force. But what about the vertical? If you consider the vertical projection of this guy, there is nobody to fight that and to keep this point in steady equilibrium, meaning that this should be zero and this should be zero as well. Then we don't need to say that the links are perpendicular to each other, and the links are kind of when we have two links and they are not on the same line, it's better to say that those links are not in the same line. Then let's complete this special case, and we have two links and no external forces on the joint, and those links are not let's complete this, are not on the same line. If they are on the same line, meaning that they can cancel out each other, but right now no, they are not, and this is zero. Okay, right now we need to double check F again, because we got F with a new arrangement. I have 1, 2, 3 links, and I cannot say two of them are in front of each other, and then it doesn't give us any zero force member. Then meaning that the whole structure would be composed of these links. This is the first link which is working, this is the other one, and the structure could be simplified to something like this, meaning that we ignore this part and we ignore this part, meaning that the parts which are under tension or compressions are this, These 4 links are not doing anything for us in this configuration. These 2 as well. But if I have some external forces, they would play their role. For example, if you have this force here, you cannot say these 2 are 0. And the same is story here. As long as there is no external forces, yes, these part of structure is not working. But we may have different scenarios. For example, in one scenario you may have some forces here, another scenario you may have other forces here. And you may have this question, why we need these guys? Because the scenarios are different. Sometimes you have a force here, sometimes you may have another force here, and you design it for all the scenarios which are possible for this structure. Then if you have just this scenario, actually you can get rid of these ones and you don't need to design your structure like this, but you may have some other scenarios as well. Okay, let's continue our examples and go to the next example. Try to find the zero force members. This is one of the zero force members, this is the other one, and right now I start to double check the points. Point A has 2 links, but we have external forces, then it's not a special case. Point B, we have external force 1 2 3 force 1 2 3 links connected to that, it's not as a special case here. Point C, we have external forces, is not zero force member, doesn't give us any zero force member. We did this and we got a zero force member. Point E actually has 3 links, and we cannot say 2 of them are on the same line, meaning that we have all of them with some forces and there is no zero force member at point E. Okay, let's continue and do some other examples here. Let's try to figure out which one is zero force member. I start from point A, we have external forces. Point B give us this as a zero force member, then I put a cross on that. What about point C? It has 4 links and we cannot say there is a zero force member. Point D has external forces, point E has external forces. Point F, 4 links. Point G, already one of the links connected to that is already zero force member, we can ignore this. 1 2 3, 2 of them on the same line, meaning that this should be 0 as well. And the last example here, let's try to figure out what is happening here. A, external forces. B, 3 links. One of them is like perpendicular to the other ones, then we have a zero force member. Point C has 5 links, cannot have any zero force member. Point D gives us zero force member. Point E has external forces. Point F, one of the links is already gone, the other one can be a zero force member. And the point G has external forces, and the point H has external forces, and point I has external forces as well, meaning that in this structure we have 1 2 3 links which have zero force, and we can ignore that, and that could be a very simplified version of this when we are going to solve that. Then at the beginning of solving any trusses, we try to find the zero force member, and finding that would be very helpful, help us to get rid of them and make the structure with less number of links and in the next videos I would show you what are the next steps after finding the zero force members to find the links forces. Thank you.